I mean, there's nothing different. I had one for a long time and not ever done it. It's pretty secure. Hopefully it won't. Okay, all right. So, right here we're going to be going backwards. Okay, we're going to do a few together, and then you guys are going to finish these up. So, we're going to be going backwards. We're given the equation, and we got to pull the information from the equation. Okay? So, for example 1, I've got y equals 20,000 times 1.04 to the x power. So, the initial value here, that's my a, which would be this part right here. So, my initial value would be 20,000 something. Okay? My percent growth, that comes from the b, but I've kind of got to go backwards here. You might just be able to look at it and see it because you've done this several times. But if you're not, to go backwards to find the growth rate, I've got 1.04. If I change it to a percent, that is 104%. And then I'd subtract the 100 that I start with, and I'd get 4%. Alright, so I have a 4% growth rate. Some of you guys may have been able to see that automatically just because you're used to writing those equations. And if you can, that's fine. So, for these, we're going to give a possible scenario. So, we start with 20,000 of something, and we have a 4% growth rate. What do you think, Jesus?
You know how you said that if you put money in your savings, you get...
Uh-huh.
Yeah, you can get 4%.
Okay. So, you could... So, Jesus invest $20,000 in an account that gets 4% interest compounded annually. Okay, so that would be a very good example in this case, except for maybe Jesus doesn't have $20,000 right now, but one day, all right? Yeah. Okay. This could be a population growth. You should have a city with $20,000 or 20,000 people growing at 4%. That would be reasonable. Now, there's some things that would be unreasonable for this. You would not say you would not say that the world population is 20,000 and it's growing at 4%, because the world population would be much larger than that, right? You wouldn't say, you might say the value of a small company is $20,000, but you would not say that Apple is worth $20,000, right? It's worth a lot more than that. Okay? I don't know, but it's a lot more than that. Okay? Alright, so let's look at the next one. Okay? This one's a little bit trickier. So, initial value is always, or usually a little bit easier to find. It's just that first number, that's your A. So this is 4 here. Now, if you're wanting percent growth, that 2 right there is telling you that whatever you're talking about is doubling, but your percent growth is not 2, or even 200, okay? So do the same thing we did on the last problem. 2, if you move that decimal place, is 200%, but you've got to subtract the 100. And so you get 100% growth. Okay? This is a little bit backwards. Students get it mixed up. 100% growth tells you that something is doubling. Okay? 200% growth would mean it's tripling. 300 would be quadrupling. Right? It's a little bit backwards because you want to say that doubling would be maybe 200%, but it's not. Okay, so your percent growth is 100. Now, so you could either say you have a growth rate of 100%, or you could say that something's doubling. So, in this case, You could say that you invest $4 in an account that doubles its growth every year. It could happen. It's not that likely to happen, right? First of all, you're probably going to invest more than $4, and you're probably not going to get an account that's doubling because that's crazy amount of growth. It could happen, but it's definitely going to be some high risk stock market stuff if it is. So something better to use for this might be more like the situation we talked about with the Pay It Forward movie. So let's say, but let's do a more negative approach to it. Let's say that 4 students start a rumor. Okay? Each student, how many students would each student tell? 2. Each student tells 2 students. Okay? And this is just an equation, so each stage of that gives you how many people know. So before you know it, the whole school knows about this rumor that started. And Miss Melissa's office is full of crying children. Okay? Alright. I'll do 5 instead. I'm sorry, that is 6. Are they numbered correctly? Okay, never mind. That is 6. Let's do 6. Because 6 is weird. Why is 6 weird? I got a 4. I don't know if 4 is my A or my B because I've only got one number, right? Okay, so 4 is being raised to the x power, so 4 has to be the B. Okay? 4 has to be the B. What's the A? It's not 0. Because if I have 0 times 4 to the x power, that's just going to be 0, right? It's got to be 1 times 4 to the x power. So my initial value is 1. What would my percent growth be? It is 300 because I would take 4, which is 400%, but I've got to subtract 100%. Okay, same thing every time, which gives me 300% growth, which tells me that what I've got is quadrupling, right? The 4 tells me it's quadrupling. That is a 300% increase. Anybody got a scenario for that? What? But then each one of those cars is not going to buy 3 more cars.
Maybe it will.
It won't, nah. And you would have to buy 4 cars, so probably not. And then you sell each of those 3 tiny boats and get 3 tinier boats. And it'd be 4. That wouldn't work very well. Okay. Okay, it's got to be something here, guys. Quiet. Quiet.
The bunny situation.
Okay, you could start. Well, you do have. If you do the bunnies would work, except for if you have 1 bunny. Are you ever gonna have more than 1 bunny?
No.
You gotta have more than 1 bunny to do that. One person has strep throat. They infect 4 people, and each of those infect 4 more, and so on. Okay?
Oh, okay.
Okay.
Got it. Yeah.
All right. to finish these notes for me. So finish these, do the initial value, the percent growth, and write me a possible scenario for each one. So you've got two things, that worksheet if you did not get it finished, and then finish these notes.